Hello everybody. I'm glad to start with you the new course, which is Introduction to Digital System uh, for electrical and computer engineering students. I know that you have four courses, and these are electrical and electronic circuit analysis, instrumentation and measurement, and calculus and statistics. In this course, we are going to discuss the digital systems, how we create, let me say, manufacture or create computer based on digital systems. We're talking about now starting from principles, numbers, and so, and then we move to the higher applications and flow registers and so on. As usual, we start with the program learning outcome. You are familiar, I guess, and level 2 students are now familiar with the program learning outcome. They are 11. We already read them for you in level 1. And here to mention the course learning outcome and how they are related to the program learning outcome. We have 4 points to be covered this semester. These are apply number representations, operations, conversions, and then simplify the operation of digital logic gates using Boolean algebra and other digital logic techniques, and construct and analyze various representation of logic functions and perform conversions between them, and finally examine the operation of sequential circuits, which is called the flip-flops, and use them in logic circuits. Here we are talking about logic, digital and logic circuits. Okay. Now, these are, as you can see, we are covering here PLO number 2, number 4, and number 5, and you know them as I mentioned. Here I advise two references. The first one is Digital Fundamentals by Floyd, and the second one is Digital Design by Mano. Floyd is more simple, easy. The students like this textbook. Now, the first topic is the numbering system. I mean, in mathematics, you are familiar with real, complex, and um, other numbering system. But here, we will move a little bit into the systems related to the computer itself. So, um, let me give you an idea in general about the lecture and the course. Now, we are going to learn how the computer designed. Okay, because computer designed based on numbers, dealing with numbers, and these numbers represented by building circuits. You will see some sort of link between the hardware I'm going to discuss with you in electrical and electrical circuit analysis with this course, digital system, where we are going to see how the numbers represented as a software, let me say, where how it's represented as a hardware in electrical and electrical circuit analysis. Then we are going to build the computing machine based on this discussion. So digital systems, we are going to learn them and understand the decimal numbers, binary and octal numbers. You heard binary numbers before, maybe octal numbers, but we are going to learn how we deal with them, how we convert from one into another, how we use the operations, addition, subtraction, multiplication, division, and so on, based on these numbering system and the conversion, as I mentioned, between these numbering systems. I put here photo for many applications of digital systems. Okay, compute the new technology. The new technology is based on what you are going to study in this course. I'm talking about computer, smartphone, tab, and so on. Now, digital computer systems use discrete amount of data. You may say, what the meaning of discrete? We know the continuous. When, as example, I sketch any waveform this way, it's continuous. When I sketch another waveform this way, and I stop here, discrete it become. I stop here, it become discrete. You see, this is the difference between continuous and discrete signal. You are going to study them and become more familiar with them in next semester in signal and systems course called signal and systems. But in general, when we talk about the continuous time, okay, all the time, this is one situation on one picture. And another picture when we're talking about having the data hourly data, only taking the measurement every hour or every 10 hours. This is called discrete because it's not taken all the time, specific parts of the time. So in computer, we will use discrete amount of data. Examples about the data we are going to deal with is the alphabet, the 26 letters as you can see here. Okay, 26 letters. Okay, and the 10 decimal point from 0 to 9, we use them in our calculation, the calculator, in different topics we are studying. Now, in discrete, we can build large, let me say, quantities using discrete. You know, words made of letters. So when talking about text, we're writing pages of text. Okay, this is large data we need to enter to the computer. I mean, the computer cannot understand the word itself. It should be converted into digits, numbers, and the computer will learn, will understand what these represent. Okay. Also, the numbers, it's not all the time it's integer, sometimes decimal. Okay, contain decimal point. As you can see here, we have decimal point. How we represent this is what we are going to discuss. But in general, the computer work according to 0 and 1, on and off, similar to the switch, on and off, 0 and 1. I show you here switch. You see here the switch. When it's connect, the voltage VCC, which appear here, whatever it is, 5, 10, whatever it is, this means that we have 1. And when the switch here connected to the ground, which is 0, then we have 0. In this way, we produce 0, 1 in hardware. And this is what the computer understands, 0 and 1 state. It's easy to represent by voltage currents, as I will explain here and in another course in electrical and electrical circuit analysis. And we use it in different circuits. A modern computer contains billions of circuits in one chip, in one small chip. Now here a comparison between number systems. As you can see here, we have decimal, binary, octal, hexo. Okay, for decimal, the base is 10. It means each number multiplied by the base rises to power. As example, if we write 52, 2 in the is multiplied already by 10 to power 0 because 10 to power 0 is 1. But 5 is multiplied by 10 to power 1, which means 50, right? In this way. So all the time, each number is multiplied by the base rises to power. And decimal is from 0 to 9, as I mentioned, while binary, the base is 2, it means 2 to the power 0, then 2 to power 1, 2 to power 2, and so on. And we have only 2 digits, 0 and 1. While octal is, the base is 8, so 8 to power 0, 8 to power 1, 8 to power 2, and so on. And the numbers from 0 to 7, there is no 8, 9. And hexo, as you can see here, hexo is 16, the base is 16, and the values is from 0 to 9, which is the 10 digits in decimal, and A, B, C, D, E, F, which represent 10, 11, 12, 13, 14, 15, as I will explain later. Now, decimal used by human, but it's not used by computer. Computer cannot use it. We need to convert it. While binary cannot use by human, they don't use it, but it's used by computer, so we can convert. And octal and hexo cannot use but we can, after we learn the binary, we convert to octal and hexo because it gives large data together in one, as I will explain later. Now let's understand first the decimal numbers. Decimal numbers, as I mentioned, from 0 to 9. These are the 10 digits we are dealing with. And if we represent them, you see this number 8653. This 3 is 3 multiplied by 10 because the base is 10, rises to power 0, which means 1. So 1 by 3, 3. And the 5 here is 5 by 10 to power 1, which means 50. And 6 here is 10 to power 10, 2, which means 600. And 8 here is 8000. You see here? When I add them together, I come up with the original number. This is how we represent a decimal number. What about fractions? Fractions, as you can see here, we have fraction. The same thing could be applied. It means from 4 to 9, these represented as I explained in the previous part. Okay, here we are. Clear? What is left? 3, 5. Now, 3 is multiplied by 10 to power minus 1, which means 0.3. And 5 is multiplied by 10 to power minus 2, which means 0.05. You see? The same way we represent the decimal number, okay, if it's contain fractions. And this is how we write it, okay? The number between two brackets and subscript here 10, which means the base is 10, which tell me that this is decimal number. And you may ask why we use 10 digits. Simply because we have by nature 10 fingers, right? So we use 10 digits. Now let's go to the second system, which is the binary number system. In binary number systems made by what we call it binary digits. So they take the first letter, which is B, and the last two letters or three letters, which is ITS, we produce what we call it bytes. Bytes, it means the number, either 0 or 1. One number. One number is byte. Okay? When we say 0, this is byte. When we say 1, this is byte. Okay. How we represent the binary number? Have a look here. You see, here is a binary number between two brackets and the base is 2, which means that the first number, this number here, this number is the least significant bit, and this number here, the last one, is most significant bit. So the least significant bit, okay, we started here, is 1 by 2 to power 0. And the second one, number here, this number, okay, is 1 by 2 to power 1. And the 0 is 1 by 2 to power 2. And 1 here is 1 by 2 to power 3. Now if we find them, let me say here 2 to power 0 is 1 by 1, 1. 2 to power 1, 1, 2 by 1, 2 plus 1, 3. And here 0, 3. Then here 2 to power 3, 8. 8 plus 3, 11. So we wrote it in this way to say that this is 11 in decimal. The base is 10. You see? So if I'm given 11, I represent it by binary in this way, as you can see. What about the fraction? The same principle apply in decimal is apply here. You see here, this number, it's okay, it's fine. We learn how to write it, as you can see here. Okay. But this 1, 0, this 1, 0, okay, this 1, 0, 1 is multiplied by 2 to power minus 1, and 0 is multiplied by 2 to power minus 2, similar to what we did in decimal. Now we learn how to represent decimal number, how to represent binary and convert it into decimal. If binary contain fractions, how we represent it also. Now it's worth mentioning here that if we have 8 bits, you see this number? 8 bits, this is 4 and this is another 4, 8. We can call it byte. So when you hear always byte, okay? Byte, it means 8 digits, 8 numbers, 8 bits. And if it is represented by 4 only, we call it nibble, okay, as you can see here. Now just here to summarize this slide, you can see here